Please let me know if the screen is visible. Okay. Good evening, everybody. I welcome you all to the 10th week of live interaction sessions for the NPTEL course Bioinformatics Algorithms and Applications. I hope the screen is visible to you all. Please use the chat box as usual to enter your answers. So this week we are going to look into week 10 topics: computer aided drug design part 2, virtual screening parts 1 and 2, and QSAR parts 1 and 2. Right. So the first question, a rather simple one. Drugs are approved by option A FAD, option B FDD, option C FDA, and D FAAD. It's more like a general knowledge question. So I haven't connected my writing device. Thank you, Mani. Thank you, Nagamani, Malini, and Filza. So you're all right. Pointing out it's option D, C, of course. Food and Drug Administration is in charge for, of course, this is according to US Food and Drug Administration, which controls the approval of foods, items, food products, and drugs. Okay, question 2. Which of the following is not a docking program? Option A, Autodock, B, Glide, C, Bio 3D, and D, Gold. Thank you, Devangana and Malini. Any other options? Okay. Let's take another half a minute. fills up. So, if you're right, I mean, we know Autodock obviously is a docking program, so that removes A out of it, and Glide is also a ligand receptor docking program. But Bio 3D is a imaging or viewing platform, right? Contain utilities for the analysis of protein structure, sequence, and trajectory data. And Gold again is protein ligand docking software. Therefore, this is the only option which is not a docking program. Question 3. Which of the following statements about QSAR is correct? QSAR can be used to identify and optimize leads. QSAR can predict admit properties. Multiple regression method is used in QSAR. And D, all of the above. Which of the following statements about quantitative structure activity relationship is right? Nagamani says B. Others? Debagan also agrees with B. Any other option? So QSAR can be used to identify and optimize leads. Is that true? True, right? And QSAR can predict admit properties. Yes. What are the admit properties? Absorption. I have a picture here. Distribution, metabolism, excretion, and toxicity. So when we are talking about um, finding a drug, right, a candidate drug molecule, definitely we have to look into the admit properties, and therefore QSAR can also predict admit properties to a good extent. Option C, multiple regression method is used, which is again true, right? So all of the above options A, B, and C hold true. Therefore, D is the answer. All right. If the concept of lock and key is considered in molecular docking, the lock and key are respectively Okay, so four of you have answered C, which is very direct question, right? Protein ligand interactions. The lock and key will be again protein and ligand. That's option C. Thank you all. Moving on to question 5. Which of the following databases contains small molecules? Option A, zinc and Campbell. Option B, PDB and zinc. Option C, DDBJ and PDB. Option D, zinc and Tromble. Nagamani says A. Also Devangana. What about PDB? Any other options? Alright. So DDBJ and Tromble are sequence databases, right? So that's not going to help us. Again, PDB is a structured database, but it's not restricted to small molecules, and you will find it only in complex in case it's present with proteins or DNA or other molecules, right? So option A, as both two of you pointed out, is the right answer. Zinc, which is a free database for commercially available compounds for virtual screening, contains over 230 million purchasable compounds in ready to dock 3D formats and 750 million purchasable compounds you can search for analogs in under a minute. So that's the description in their website server. And CHEMBL, obviously we know, is a manually curated database of bioactive molecules, drug-like properties. So it also brings together chemical, bioactivity, and genomic data to aid in translation of genomic information into effective new drugs. We also have certain disease-specific information also. So option A is right. Question 6. Which of the following is a search algorithm used in docking? Simulated annealing, torsion angle, Wunsch Needleman, Smith Waterman. So two options are bogus here. Probably three, but two immediately you can recognize. Thank you, Nagamani. Focus on the algorithm. Thank you, Devangana. So we are talking about flexible docking methods under which you have these algorithms under stochastic search, namely simulated annealing, genetic algorithm, hybrid global and local search, and Lamarckian algorithm, Lamarckian genetic algorithm, and so on, right? So amongst these simulated algorithm, annealing and genetic algorithm were discussed in detail. Torsion angle is not an algorithm as such, so that dumps it. Wunsch, Needleman, and Smith Waterman are alignment tools, right? Scoring um, methods. Therefore, the only right option is simulated annealing. Question 7. Which of the following are measurable molecular descriptors? Option A, refractive index, B, polarizability, C, surface area, and D, all of these. Okay, the Bangla says A, Nagamani says B. Any other options, B or C? Okay, Malini sides with D and Pilza too. Nagamani goes with A now, so it's 2 and 2. Any other answers? So amongst molecular descriptors, you have some that are measurable and some that are calculated. So under calculated you have surface area, and since one of them is gone, all of these will go away. We are talking about measurable molecular descriptors. And you also have polarizability, therefore P is also gone. And apart from that, there is molecular volume, molar refractivity, maximum positive and negative charge, and so on. So under measurable, We have density, pKa, ionization potential, refractive index, dipole moment. Therefore, you have option A as the answer for question 7. Alright, question 8. Which of the following is not a major component of force field based bucking scoring? Option A, van der Waals, B, electrostatic, C, covalent interactions, and D, none of the above. Thank you, Nagamani. Thank you, Devangana. Okay, Malini also agrees. Any other answers? So, how's force field scoring made? Energy is calculated as summation of I for ligand and for protein. Where this is van der Waal component of the energy calculation, and here is the electrostatic component. So both these are a part of force field scoring, right? So none of the above is wrong, and therefore the right answer is covalent interactions. So all three of you are right. Question 9. The IC50 values of three protein ligand complexes are 6 nanomolar, 7 nanomolar, and 4 nanomolar. The IC50 values are related with the combination of hydrogen bond donor, hydrogen bond acceptor, and polar surface area, with 232 respectively for hydrogen bond donors, 232. That's all right, Kritika. We'll be solving it now. Okay, Nagamani says the answer is 3, but others can uh, evaluate the answer. And hydrogen bond donor is 232, acceptor is 344, and polar surface area 1, 2, 3 respectively. The IC50 value of a compound with 3 hydrogen bond donors, 3 hydrogen bond acceptors, and a polar surface area of 2 is dash. And now the money has said 3. If anybody else is working out and giving an answer, we'll wait for that and then start solving it ourselves. We have a similar question in this year's assignment. So if we do this one, you'll be able to fills up how to evaluate XYZ variable in the equation. So you can use your scientific calculator. Once you have formed the three equations, use your calculator. If you can get your calculator now, we'll do it together. Mm, you can sit and do it manually, but you never know, you won't have the time to do trial and error. Even if it's a two variable equation, that's easier, but with three it's going to be hard, right? So I think most of you will have a scientific calculator, so use that. I hope you should, or at least there should be a calculator in the monitor, or a pop-up calculator or something, but I can check with the other TAs who conduct the exam to give you a proper answer to this. And remind me to confirm this during the next session. Any other answers apart from Nagamani? So here IC50 values are a function of hydrogen bond donors, hydrogen bond acceptors, and polar surface area. I'm just writing the given and I'm still waiting for answers. So you can anytime drop in. So for the first part, you have 6 nanomolar, 7 nanomolar, and 4 nanomolar. These are the three protein ligand complexes, IC50 values for these three cases. And they are related with the combination of hydrogen bond donors. So what I'm going to do, I'm going to have this as X, Y, and Z. Okay, 6 nanomolar is related to hydrogen bond donors as 2, Devanganas is 5. Okay, 2, 3, and 2. And hydrogen bond acceptors 3, 4, and 4 respectively, for which case 6, 7, and 4. You should not write it on horizontally because all of these are acceptors and they are going column wise, right? So 3y, 4y, and 4y plus what is the polar surface area? 1z, 2z, and 3z. So these are the three equations that you have. Now use your calculator. Once you switch it on, you will have a button called mode. And this is a Casio calculator that I use, which is FX991MS. So some people might have it in mode where you will have equations displaying as a matrix already. If you have a calculator that looks like mine, you will have to press mode several times, one, two, three times, and then I get the equation option, which is as 1. So once I press 1, I get a question which says unknowns 2 or 3. Or if you press the right arrow, you will have degrees 2 or 3. So if you have a quadratic equation or a cubic equation which has x cubed plus some constant x squares and constant x plus some is equal to 0, or you have it on the other side another constant, then you can use the degree option. Otherwise, we will use go press the left and right arrow to switch between options, and you will have unknowns. So under unknowns, you have 2 and 3, and press 3 because you have x, y, and z here, right? So I'm going to erase all this. So click on 3, and immediately you have A1 question mark. At least that's how it points in my calculator. So it's going to be A1, uh, B1, C1, A2, B2, C2, A3, B3, C3 is equal to D1, D2, D3. This is how it is going to solve. Don't mind the squiggly writing. My pen is bad and I don't have space here. Alright. So does this represent some the way in which we have written the equation? So you are essentially solving for 2, 3, 1, 3, 4, 2, 2, 4, 3, and you have 6, 7, 4. All right. So now enter these values. A1 is equal to 2, B1 is 3, C1 is 1, D1 is 6, A2 is 3, D2 is 4, C2 is 2, and D2 is 7. A3 is 2, B3 is 4, C3 is 3, and D3 is 4. Once you press equal, you will get x is equal to 1, y is equal to 2, z is equal to minus 2. Now, they're asking the next part of the question. The IC50 value of a compound with 3 hydrogen bond donors, 3 hydrogen bond acceptors, and a polar surface area of 2. Oh, then don't focus on I thought it was going to be 1. And a polar surface area of 2 is what? So what is your fourth question? I mean fourth equation here. Let me take a different color. So now, okay, Nagamani. So she also sides with 5. Let's see if we are getting 5. So your question is 3 HBD, which is x is equal to 3. I'm sorry, 3x So HBD is 3, and bond acceptor is again 3, and polar surface area is 2. And they're asking what is the IC50. So 3x plus 3y plus 2z is equal to what? 3 into 1 plus Malini also says 5. 3 into 2 plus 2 into minus 2, which is 3 plus 3 2s are 6 minus 2 2s are 4. 9 minus 4 would be 5, right? So all three of you are right. Kritika, was this clear to you? And Filza? So the answer is 5 nanomolar. So again, in this current year's assignment, you will have another problem. You can work it out right now with me, and that should seal the answer in your brain or method. Question 10. Which of the following depends on empirical based scoring function? Did we already have this? Oh, okay. Similar question. One more question based on regression coefficient. Oh, we will get there when we do the problem. Nagamani says C. Also Devangana. Anybody else? What about A, B, and D? Others? Okay, orthodox and gold are force field based scoring functions. And PMF is that leaves only glide, which is empirical scoring based right? So option C is right. So with that, we'll jump into the current assignment. 2D QSAR deals with option A molecular properties, option B connectivity indices, option C surrounding atoms in the structure, and D all of the above. Thank you, Devangana and Malini and Nagamani. So, what does QD deal with? I'm not going to write the entire uh, story here, just the keyword, right? So, this is 3D, this is 1D, that's 2D, right? From 4, 5, and 6D, you have inclusion of ensemble of ligand configuration, and 5 will be inclusion of representing different induced fit models, and 6 would be different solvation models. I mean, I could write all those down, but I think you already will have notes, or the lectures are always there. Welcome, Vijayanta. I think you had a problem with week 9 or something. I have forwarded your concern, and I hope the other TA got in touch with you. Something different, used fit models. And this one is inclusion of an ensemble of ligand configurations. Alright, this is just a ready reckoner for you. So, the right answer is option B. Question 12. In protein ligand docking, two important bottlenecks are option A binding site prediction and conformational sampling, B conformational sampling and scoring function, C binding site prediction and scoring function, and D none of the above. We have binding site prediction, conformational sampling, scoring function. Those are the three things that keep combining in different ways. Thank you, Vijayata. Devangana says B. answers? Option A or D? No takers. Thank you, Kritika. So, what are the major problems in docking or main components of docking? One is the search algorithm, and second is the scoring function, right? So, the search algorithm is all about generating a large number of poses of a molecule in the binding site. We are not predicting the binding site, but we want to generate a large number of conformations or poses of a molecule in the binding site. And the second part is calculating a score or binding affinity for that particular pose. So you are scoring. So pose and score. These are the two things which are important for docking. Right? So conformational sampling, yes. Scoring function, yes. But the combination is available only with B. And therefore C is wrong. But B has both conformational sampling and scoring function. Alright. Question 13. QSAR involves the following steps: construction of model, generation of descriptors, collection of ligands with experimentally known activity. Thank you, Vijayanta. And question option point 4 is validation of model, and 5 feature selection. Thank you, Divamana and Malini. So this is quite clear, right? Although we know that the steps are start with collection of ligands with experimentally known activity, followed by generation of descriptors, and then selecting feature selection, and then you will construct a model and finally validate a model. Even if you didn't know all that, if you look at the options, validation of a model will be the last step. So this should be 5, and that gives you 2. And apart from that, before validation of a model, you will have construction of a model, right? Which is present only with 3. And ideally, you would know that collection of ligands is first important, and only then you will be able to generate descriptors, and then you will refine it better with feature selection, construction of a model, validation of that model. So gives you 3, 2, 5, 1, 4. Thank you, Navani. So all of you are right. Question 14. Which of the following uses a force field based scoring function? We just answered this question, so I don't think there should be any problem. Thank you, Vijayanta. We had just the same question, right? Autodoc as well as Chem score. But last time we had gold score here, I think, because the question was for empirical scoring function, so the other option was for uh, force field based scoring function. So as usual, PMF is a knowledge based scoring function. Light and chem score would be empirical, and it leaves auto dark as the only force field, right? So Vijayanta, Nagamani, and Malini got it right. Option A is the right answer. Question 15. Genetic algorithm is a dash. Again, this was discussed during one of the questions. Is it option A, systematic search? Option B, stochastic search? Option C, greedy incremental search? Option D, dynamic search. Okay, thank you, Vijayanta, Devangana, Nagamani, and Malini. I don't think this requires any discussion, right? Stochastic search algorithms have genetic algorithm, simulated annealing, and all the others that we just discussed, right? Taboo search, hybrid global local search, Lamarckian genetic algorithm, and so on. So option B is the right answer. Question 16. Chemical complementarity score mainly depends on hydrogen bond donors and acceptors at protein site, hydrogen bond donor and acceptors at ligand site, hydrogen bond donors and acceptors at protein and ligand sites, D charged atoms. Okay, I've got four C's from Jayanta, Nagamani, Devangana, and Malini. So no other option, no other takers. So how do you calculate the chemical complementarity score? It is by dividing the accessible protein surface area, into zones as hydrophobic, hydrogen bond acceptors, hydrogen bond donors, and you do a similar scoring for the ligand also. Therefore, it has to include both protein and ligand sites. Question 17. The IC50 values of three protein ligand complexes are 6 nanomolar, 15 nanomolar, and 2 nanomolar. Yes, Kritika. Now I want you to solve this with me and drop in the answer. So it's a very similar question to what we just did, only the variables are changed. The IC50 values are related with hydrogen bond donor as 321, 2 and 1 respectively, hydrogen bond acceptor as 5, 6, and 5 respectively, and polar surface area as 4, 1, and 2 respectively. The regression coefficient of hydrogen bond donor is. First, solve for x, y, and z. Let me write down the given. These are the equations. So similarly, use the matrix method and solve for x, y, and z. Thank you, Divangana. So what do you get? X is equal to 7, y is equal to 1, z is equal to -5. Kritika, did you get this? And all the others who are doing this problem right now or had an issue with this question. So hydrogen bond donor is X here, acceptor is Y. I mean the effect of that or polar surface area is Z. And IC50 is a function of these. And what you're essentially doing here is you're having data from three equations and you're trying to predict what will be the effect when you're given three such data sets for fourth one, or this you're basically doing regression here, and through regression analysis you're finding the answer for x, y, and z. So when they ask what is the regression coefficient of hydrogen bond donor, you are actually talking about HBD, which is x here. And what is the coefficient? 7, because the coefficient is this one. So next, when you have, um, although you might think this is the variable here and you have a constant here, so you might think 3 is the coefficient for x, but next your equation becomes IC50 is equal to 7 into, maybe I call it A, plus 1B minus 5 into C, where A will be the value for hydrogen bond donor, uh, whatever, like what you had in the previous question when we did, right? Whenever some value for hydrogen bond donor or hydrogen bond acceptor or hydrogen bond or polar surface area is given, you know what regression coefficient each of them have. So for these values of hydrogen bond donor and these values of hydrogen bond acceptor and these values of polar surface area, I'm getting IC50 as 6, 15, and 2, which means they have a coefficient or constant in front of them, which I'm finding by regression. And I don't know that because I only have the experimental values or calculated values. Now because I have three equations, and three variables. I have found out the regression coefficient for hydrogen bond donor, hydrogen bond acceptor, and polar surface area, which are 7, 1, and -5 respectively. Now, this is the coefficient for donor, acceptor, and polar surface area. So, if you are given values for these three, you can combine them with the coefficient and arrive at the IC50 value. I hope that was clear and I didn't mix up too many things as I spoke. Alright, so shall we look into the next question, which is in continuance with 17. So we got the answer right. 7 is right. For the data given in question 17, the IC50 value of a compound with HBD is equal to 2, HBA is equal to 4, PSA is equal to 3 is what? So from our memory we know that 7A plus 1B minus 5C. And when you substitute 7 into 2 plus 1 into 4 minus 5 into 3. What will that be? 7 to 14 plus 4 minus 5 3s are 15, which is minus 1 plus 4. The answer is 3. Thank you, Devangana, Nagamani, and Malini. Kritika, did you get 3? Filza, are you following? Yes. So if we check, the answer is 3 nanometer. Cool. Okay. Question 19. The binding affinity of a protein ligand complex is estimated using option A, search space, B, search algorithm, C, scoring function, and D, virtual screening. Thank you, Vijayanta, and Malini and Devangana. And Navini. Thank you, Filza. So 5 votes, no alternate answers. I think we can give it to C, right? So the binding affinity is estimated using scoring function, not search algorithm, not search space, and not virtual screening. It is undoubtedly C. Great. Question 20. Percentage of test data points in a jackknife test is option A 100%, B 99%, C 70%, and D 33.3%. Devangana says B. Nagamani says A. Any takers for C or D? Filza goes with B. Malini goes with A. This is nice, interesting. Vijayanta goes with B. Any more votes? For this question, I haven't attached any images supporting information or document, but I think I should, given the difference in opinion amongst you all. Before I upload the PPT, maybe I can include something. Any other answers? So in jackknife test, n minus 1 data are used for training, and the prediction, the left out 1 data, is used as test or prediction. So it's more like a training set and test set, right? To clarify, and how many times is this done? For n times. Let us take um, a case where you have 5 data. Okay, let's have, okay, that's it. So in first case, I hope this is visible. So I'm going to write the training set in orange and the test as, I think by now you will get the idea of what I'm trying to show here. Okay, so how many are here? 5. So I'm doing it n times. How many data is there? N is equal to 5, and I'm doing this test 1, 2, 3, 4, 5 times, and each time I'm having, I'll change the color. It will be pathetic, not be very visible. So you have 4, which is n minus 1 as training, and 1 where you make the prediction. I'm doing this 5 times. Therefore, go to the question again. Percentage of test data points in a jackknife test is. In first case, you have this as your test data point. Second case, you have 3 as your test data point. In third case, you're having 4 as your data point. In fourth case, you have 2 as your test data point, and last one 5 as your test data point. So have I covered all my data? Since I'm doing it n times, where I skip n minus 1, where I take, not skip, n minus 1 data points as the training set, and I do the prediction for the last data point. So essentially 4 These last four are used to train, and you're making the prediction for first data point. Okay. Similarly, the ones written in blue are not exactly 2.55. This is the data point for which test is made. So the percentage of test data points in a jackknife test is, it is essentially covering all the data points, right? So can I go with 100%? I mean, this is how I visualized it, but I will definitely look for some online material, or some textbook description, or source picture, anything that will corroborate or add to this explanation, or if it's different also, I will mention it to you in the next class. This is how I viewed it, and therefore I felt 100 is right. If anybody of you have any discrepancies or disagreements, you can tell me now. Shall I proceed? I think I have a couple more, or three more questions before. I hope everybody is okay with question 20. I don't know if my net is poor because I'm not getting any messages here. Um, you sometimes it's application based. I mean, I have used the same lectures. I understand that this was not covered in the lecture, but you cannot expect. A lot of questions are very direct. But sometimes you will have to apply your mind, right? Amongst 10 questions, I think only one or two are given like that. I will definitely try to give some assisting materials. But to answer your question, how will we be able to answer? Is one, it is an assignment question and it's not directly coming in your examination also. So you can always read more, discuss with your peers probably. And there's also online material. At the end of the day, you have to apply a little. And it's alright to sometimes be wrong also. That's how we all learn, right? We cannot always be right. Sometimes questions should tease our brains. Okay. Question 21. In case this answer is wrong, or something, I will let you know. Or if my explanation is wrong, I will definitely put it up in the description, or take this up when I begin the session next week. Okay. This is my take on the question. Question 21. Comparison of physico-chemical properties with known active compounds could reduce the initial data set to. Again, you will not have a formula for this. It is just to a practical way of thinking and seeing which is the most appropriate option. So focus on the question again. Comparison of physico-chemical properties with known active compounds. You already have some known active compounds, and that is helping you filter the initial data set. So what would it be? Option A, 50% or less, B, 95%, C, 90%, and D, 85%. Take a wild guess. Have you responded? Am I unable to see? Okay, so there's a problem with my phone. Okay, so S ma'am was for 20th question, I believe. All right, so A, and A. Thank you, guys. So that's clear, right? When you have a data set of, let's say, some 20,000 compounds, but when you know how an active compound looks like, or these are, you have, say, even five structures of active compounds, known active compounds, then you can use those characteristics to filter or uh, go through the initial data set and reduce it further. Definitely, it's not going to be 95, 90, or 85%. Right? When you know something is known active compound, you'll be able to reduce it well below 50% or around 50. Right? So, Nagamani, Vijayanta, and Phils are right. Option A is right. Question 2. If the Pearson's correlation coefficient between the two sets of data is 0, then option A, no correlation, option B, positive correlation, C, random relationship, and D, negative correlation. Okay, two answers for A. Thank you, Filza and Vijayanta. Thank you, Nagamani. So that's another straightforward question, right? Pearson's correlation coefficient R varies between -1 to +1. I mean, it's a range of values. So 0 means no correlation, -1 would be negatively correlated, and +1 would be positively correlated, right? So no correlation is the right answer. Choose the application of docking scores. Is it option A to fix a particular position of the ligand? Option B to reduce the degrees of freedom? Option C to rank the active compounds? Option D, all of the above. Excuse the disturbance. Okay, I've got four C's. Thank you all. I'm happy that there are no all the aboves. So it's definitely to rank the active compounds, right? It's not to fix a particular position of the ligand or to reduce the degree of compounds. I'm sorry, degree of freedom. Just to rank the active compounds. That is where docking scores help to rank. And definitely not all the above. I think that was, yeah, that ends my presentation for today. Is there any question that you want me to repeat or something that you want to raise? I will look into the calculator query and get back to you. There was somebody else who joined last session for an issue with the portal which has been forwarded. Similarly, Vijayanta's concern has also been forwarded. I hope remedial measures are underway. If there's nothing else, we can close down. Okay, then thank you all for joining. Have a good weekend, and I'll meet you again next Friday between 6 and I guess 7:30 p.m. Thank you, Nagamani and Devamna. Thank you for your continued active participation in the questions. Hope to see you all next week too. All right. So with that, I'm going to end the call.